So in last lecture we saw this the performance and operational characteristics of the power plant. Now whenever we considering any particular power plant, we have to consider the overall efficiency, right? Because in one particular power plant there are maybe different types of the generators are has been installed. Sometimes we are considering or we are using the combined cycle power plants in which the steam power plant or simple thermal power plant also combined with the gas turbine power plant. So in that case, whenever we are going to carry out the analysis, we have to consider the performance of the combined power plant and whatever the characteristics of the combined power plant. So in that case, if there is a combined power plant which is combined the thermal power plant and the gas turbine power plant, so in that case we have to consider the overall efficiency, not the separate efficiency. Okay, so that is kept in mind. Also, the division of the load. Okay, that is most important point because whenever we divide the load between peak load power plant and the base load power plant, we have to consider its individual efficiency, and also we have to consider its overall efficiency. How when we changes the load distribution, how the overall efficiency is going to be changes. Okay, so for that you must have first of all the individual characteristics, right? Individual characteristics of the generators, and then the combined characteristics of the generator. Because sometimes what will happen whenever we combine two different generators, or whenever we combine the output of these two different plants, in that case there is a chances of getting different characteristics. Okay, means the efficiency will be different, overall efficiency will be different. Okay, so sometimes what will happen, the base load will have the maximum efficiency, but whenever we combine it with the or connected with it with the other type of the generator or the peak load power plant, in that case its overall efficiency will reduce. Okay, so that division, okay, generally specifically the load distribution between the base load power plant and the peak load power plant, it is going to affect the economics of the power plant, right? It will going to affect the particular charges of the electricity or the total cost required for the generation. It is going to be affected. So for that, the analysis of the economic division as well as the load distribution between the base load power plant and the peak load power plant is very important. Okay, and for that you must know how to plot the performance characteristics. What is mean by performance characteristics? Okay, so generally the performance characteristics means it is the variation of the efficiency with respect to the load, or variation of heat rate, or variation of the particular output with respect to the demand. Okay, so that variation you must know how that particular generator is working along that across all that particular load. Okay, when we vary the load, how the efficiency will changes. If we considering the combined cycle, then how it will overall efficiency will changes. That you must know. Okay, and particularly we are mostly concentrating on the economical side because as we know we are constructing the particular power plant to achieve some profit, right? Because overall actually it is a business, right? So in that case we have to consider the economic side of that particular power plant whenever we're going to install or construct the one particular power plant. First of all we have to carry out the economic analysis, and for that you must know how to divide or what is the economic division between these two type of power plants or the two types of the generators are there, and how we can do that one. Okay, so there will be no need to go in deeper. Just the questions will come regarding the or explain the economic division between the base load power plant and peak load power plant, because the actual division methods of the divisions are very complex, and there will be it is not out of the scope of the syllabus for you guys. Okay, so you just understand whenever we divide the particular load between two different generators or the two different load power plants, they have to consider its overall characteristics or the combined characteristics, and also we have to connect that characteristics with the economical side of the particular power plant. And the main objective of our economic analysis is to there will be a profit. Okay, there should not be any loss from this particular power plant or the selling of the electricity. So that is our objective. Now, whenever we considering to particularly whenever we generate the electricity or the power and we sell it to the customer or the consumer. In that case, we have to consider we have to first of all carry out the or fix the tariff of that particular electrical energy, okay, or tariff of the electricity. What should be the cost we have to apply or we have to consider whenever we're going to set the tariff. Okay, there are different methods are there. In this particular point, we are going to study five different methods, five different tariff methods. Okay, so by using those methods, you can set a tariff for that particular electricity generated inside the power plant. Now this tariff of the electricity or the cost of the electricity is going to be changed with respect to power plant, right? Because each and every power plant having different efficiencies, different overall efficiencies, and also it will the input requirement or other factors are going to be affect this tariff of the power particular electricity. Okay, so generally the energy rate, which is also known as the tariff, it is depends upon the type of consumer also, right? Because the consumer sometimes the consumer may be a domestic one. In that case, tariff will be lowest. In the commercial or industrial cases, tariff will be high because the maximum demand required in the commercial and industrial sites or the industries are very high whenever we compare it to the domestic one. Okay, so in that cases, the tariff of or the we can say the cost to the consumer of particular electricity is vary with respect to the type of consumer. Okay, now whenever we considering the setting the tariff or the setting the rate of energy rate, in that case we have to consider following points. Okay, so first one is to recovery of the capital cost. Whatever the capital cost we have invested during the construction or whenever we purchasing any particular different equipments for the power plant. So whatever the capital cost we have invested, first of all, the recovery of capital cost is important, right? So for that, these particular points we have to consider whenever we set the energy rate. Okay, the first of all, recovery of the capital cost which has been invested to generate the electricity or to construct the particular power plant. Second, recovery of the running cost. So as we already know, to generate some electricity we require some fuel, right? We require some fuel in the case of thermal power plant. We required water in the case of hydraulic power plant, right? So in that case, the running cost, whatever the running cost or the operating cost is there, they have to recover that operating cost. That is the second most important point. And third one is the satisfactory profit. Okay, because as we know, overall, after all, this particular energy sector, it is just a business. Okay, so that business must be the profitable. Then it is okay to run that particular business or run that particular power plant. So satisfactory profit is also important whenever we considering the rate of energy which is going to be sold to customer. Okay, so these three factors we have to consider whenever we set the energy rate. First of all, recovery of the capital cost. Second, recovery of the running cost or the operating cost. And third will be the profit which is coming out from the particular power plant. And by using or by considering all these three particular points, we have to set the rate of energy, and that rate will be applied different for the domestic customer. It will be the different for commercial or industrial customer. Okay, now whenever we set that tariff, there are different methods are there. By using those methods you can set the tariff. Each and every method will be different. We can apply one method to the first customer, one method to the another type of customer. It is totally depends on you. Okay, so generally the general equation whenever through which we can calculate the tariff, it is like this one, which is Z is equal to AX plus BY plus C. Now Z means what? It is the total amount of bill for the period which we are going to consider. Now if you consider the 1 year or 1 month, then it is the total amount of bill, total electricity bill. That is you can relate to your residential electricity bill. Okay, so Z will be your total electricity bill. Okay, now this total electricity bill is depends upon different variables. Okay, you can see there are two variables x and y, and three constants are there. Now, what are those constants and what are those variables? First of all, the first term that you are going to see, that is the A into X, where A means it is the rate per kilowatt of maximum demand. Okay, and X means the maximum demand in kilowatt. Now, why we are considering this particular factor? Consider there is a industry person or industrial consumer is there. In industry there are many equipments are there which is required very high amount of energy. Okay, their demand is maximum in most of the time. So in that case, whenever we providing the maximum demand, the cost required for the providing the maximum demand is also going to be high whenever we compare it to the lower demand. So in that case, we have to apply or we have to uh, uh, set their energy rate by considering those maximum demand. Now, the X means the amount or the maximum demand in the maximum demand requirement in kilowatt, and A is the rate per kilowatt of maximum demand. Means consider there is a 10 kilowatt of maximum demand requirement, or 10 kilowatt or 100 kilowatt will be the maximum demand, into we have to multiply it with the rate of the maximum demand per kilowatt. So for 1 kilowatt, if you consider 1.5 rupees will be there, 1.5 rupees rate will be there. Or generally for industry or commercial purposes, its rate is very high. It is near to the 9 to 10 rupees per kilowatt or the per unit. Okay, so that is your first term which is related to the maximum demand. Okay, the second term, that is the B into Y. B into Y. B is the constant, Y is again variable. Y means what? The total amount consumed or the total amount of energy consumed in kilowatt hours or in units by the particular customer. Okay. Now, if we consider 1 month as a period to calculate the total amount of electricity bill, in that case, in 1 month, how much amount of electricity units has been consumed by the consumer, it is considered as a Y. Okay. So simply your residential, if you saw your residential electricity bill, you will find out that in particular month you used this particular 120 units of electricity. So that is the Y. Okay, so this one is the total amount of energy or kilowatt hours or electricity units consumed by the consumer, and it is multiplied by the rate or energy rate per unit. Okay, and generally for residential, as we know, it is nearly 3 to 4 rupees or 5 rupees. Okay, so we can multiply the total amount of units consumed into the rate. Okay, that will gives you the whatever the amount of energy consumed by the customer, and it gives you the total cost. That is the second term. Second term is related to the general or whatever the amount of electricity consumed by the customer, okay, or the consumed by the consumer. Now, the difference between first term and second term is that it is related to, first term is related to the maximum demand. Means here the demand, the whatever the energy consumed, it is consumed at the peak demand. Okay, it is consumed at the maximum demand. So that is related to first term, related to the maximum demand. Second term related to the actual electricity consumed by the consumer. And the third, which is the last term, that is the C. C is the constant amount which is charged to the consumer. Now, why we charge this particular constant amount? Okay, because here the constant amount it is charged because there is the particularly the power plants are situated very away from the particular consumer. Okay, so in that case, whenever we transport that electricity from the power plant to the consumer house or or that particular industry, it will require some amount or it will have some cost, right? So to uh, to get that cost, we have to charge some constant amount in each and every bill amount. Okay, so that C is the constant amount charged to the consumer during that each and every billing period. Okay, this amount is constant. Okay, it will be the vary with respect to type of consumer. okay, or the type of customer. For the domestic one or residential one, this amount is less. For commercial cases or for the industrial cases, this amount is high, because it is again depends upon the maximum demand required or whatever the voltage required in that particular consumer side. So this C is known as the constant amount charged to the consumer during each billing period. Okay, so the total amount which is consumed, which will consider the maximum demand, which will consider the total amount of energy consumed by the consumer, and C1 is the constant amount charged during the billing period. So that whenever we add those three terms, we will get the total amount of bill for the for that particular period. Okay, generally in India, we saw the for the residential, these particular period is for of 1 month. Generally, even in the commercial and industrial cases, this particular period, billing period is 1 month. In the case of agriculture sector, you will see this billing period is about 3 months. Okay, we will receive the electricity bill for the 3 months. So it is totally depends upon you or that particular uh, provider which will apply any of the tariff method. Okay, this is the general type or the general equation of the tariff method. Now based upon the different factors, there are different types of the tariff methods. The different tariff methods have a different applications. Okay, so that we are going to see. The first one is the flat demand rate. Now you will see the equation for the flat demand state, that is Z is equal to A into X. Now you can see there is only one term is there, and which is related to the maximum demand. So as we know, A is known as a rate per kilowatt of a maximum demand, and X is known as the maximum demand or the maximum demand required for the consumer. So this type of charging or the tariff method is depends only on the connected load and the fixed numbers of hours which has been used by the particular consumer. Now, this rate expresses the charge per unit of demand, whatever the demand must be there of the consumer. It is based upon that demand. This system eliminates the use of metering equipments. Now, the most important is that the fixed amount of electricity will going to be uh, uh, delivered to the particular consumer. Now consider there is one industry which having the maximum demand of 10 kilowatt. Okay, so that is the year its maximum demand. Now how this 10 kilowatt has come? Whenever we connect all the equipments in that industry at a time, means consider there are three machines. Okay, we are considering or we are connecting three machines at the same time. Okay, each machine having different ratings, right? Different power rating. One machine will have 5 kilowatt, another machine will have 3, another will have 2. So whenever we connect all these three machines at a single time, at a one time, then it will gives you the total maximum demand of that particular consumer. Now, what in this particular method, what will do? The particular supplier will produce the electricity, and it will uh, gives or they provide this particular electricity at the maximum demand. Okay, so whatever the electricity provided, it is always provided 10 kilowatt to that particular industry. Okay, now this 10 kilowatt we have to multiply with the period. Okay, for one, if you consider for 1 month we are using this one, so we have to multiply it by period and by also by the rate of per kilowatt of maximum demand. Okay, so that will be the total bill of the for that particular period. If you consider for month, it will be up to the month. If you consider for 2 months or the 3 months or even for the annually, we have to multiply by that particular factor. Now, in this case, continuously this 10 kilowatt has been provided to that particular industry. Now, the usage of that particular consumer will consume that electricity or not, it is depends upon the consumer. But the bill, whenever we calculate the bill, we have to consider the 10 kilowatt. Okay, even if that particular industry will consume 8 kilowatt for 1 week, and remaining week it is going to be consumed 10 kilowatt. But even for the billing purpose, or for the whenever we calculate the bill, we have to consider 10 kilowatt for all the month. Okay, so in this, because of this, we already know how much maximum energy which has been supplied to the particular consumer and the time period. So from that, we can easily calculate the total amount, billing amount, and that billing amount has been uh, 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 or that is a billing amount given to the consumer. Now in that case, we doesn't require uh, any instruments or the any metering equipment or manpower, because we already know how much bill will become for that particular period. Okay, so the main advantage of this particular type of tariff method is that there will be no use of metering equipment, or there will be no any need of metering equipment, and also the manpower required for this particular tariff method. Okay, so this is the basic equation. You can also see the variation of this particular method whenever we plot it on the chart. On the x-axis, there will be energy consumed, and on the y-axis, there will be total cost. So you will see the total cost will remain same, even the particular industry or particular consumer will reduces its consumption. Okay, so this type of billings, it's known as a flat demand rate. Okay, under this particular system of charging, the consumer can theoretically use 100% electricity, whatever the provided to that particular consumer. And in that case, we are using 100% use factor. Okay, here we are considering 100% use factor. Uh, now, the cost of energy per unit cost of energy will be decreases as we increases the demand, maximum demand. Okay, that is again another characteristics of this particular tariff method. The second tariff method is known as the straight line meter rate. So in the previous one we saw, it is depends upon the maximum demand. Now this straight line meter rate is directly it is depends upon how much energy has been consumed by the consumer. Okay, so you will see only second term is available here. We are only going to give the bill to that particular consumer depends upon the number of amount or the total energy consumed by that particular consumer. Okay, so the bill is directly proportional to the energy consumed by the consumer, and it is represented by this particular equation, that is Z is equal to B into Y. B means the rate for energy rate per kilowatt hour per unit, and Y is the total amount of units, electrical unit consumed by the customer. Now, the main drawback of this system is that the consumer using no energy will not pay any amount. Okay, so as we saw, it is the straight line method. So you will see that is the uh, bill amount electricity amount bill with respect to the amount of electric energy consumed. Now, whenever that particular customer will consume zero amount of electricity, it does not require to pay any amount to that particular power plant or to that particular enterprise. So that is the drawback here, because whenever we transport the electricity from particular power plant to that particular consumer, uh, we must apply some particular constant amount to that particular customer. Okay, but in this type of in this tariff method, if the customer uses zero electricity, it doesn't have to pay to that particular enterprises. So that is the main drawback of this straight line meter rate. To overcome this drawback, we discover the next type of tariff method, that is known as the block meter rate. Okay, now this is advancement in the straight line method, and then again it is advanced in the Hopkinson demand rate, or we can say the two-part tariff method. Okay, so first of all, block meter rate. Here you can see in the straight line method, you will see whatever the amount of energy consumed by the consumer, the rate for that particular electricity will be constant. The rate will remain constant. It does not changes that even if that consumer will consume more and more energy. But in the case of block meter rate, when as the energy consumed by that particular consumer will increases, If it is crosses beyond the certain limits, the rate of electricity will reduces. Means consider there is three blocks are there, 0 to 100 units, then 100 to 150 units, and 150 to 200 units. Consider there are three blocks are there. Okay. Now what will happen here? For the first block, the rate for electrical energy will be different one. Consider the rate will be 1.5 rupees per unit. Just we have to considering. Now, when the customer or whatever the consumer will consume more than 100 units, the above units which are consumed by that particular customer, above 100 units, the rate will be reduced. It may be a 1 rupees per unit above the 100 units. Okay, so that is known as the block meter rate. In the case of straight line method, whatever the amount of electricity consumed by the consumer, the rate for that particular electricity or power will remain constant. But in the case of block meter rate, each and every block or for each and every range, the rate of electricity or the rate we are going rate for the energy will going to be changes. Okay, so that is the difference between block meter and straight line method. Okay, and the basic equation that is equal to similar to the straight line method. Each and every block will having different rate, so we have to considering the different equation. Okay, it will be the z is equal to b1 y1 plus b2 y2 plus b3 y3, etc. Okay, we have to sum all these factors and you will get the total bill amount. Now here you must considering or observe this one. The b1 is less than b2 and b2 is the less than b3. So as the amount of energy consumed by the customer will increases, the rate which has been rate of the energy will going to be decreases. Okay, that is the block meter rate. Now the next method is known as the Hopkinson demand rate of two-part tariff. Okay, so in the previous straight line method or the block rate method, does not consider any maximum demand, right? But in the Hopkinson demand rate of two-part tariff, we are going to consider the maximum demand also. Okay, and this method which is proposed by the Dr. John Hopkinson in 1892, and this method charges the consumer according to his maximum demand and the energy consumption. So you will see there are two parts are there. First one is related to the maximum demand and second one is related to the energy consumed by that particular customer. Okay, so we have to multiply here by x. Okay, that is remain. So Z total billing amount is equal to AX plus BY. Okay, and the related graphical representation also you will see there will be a different rates for the different as we increases the maximum demand or as we increases the total energy consumed. Okay, so A is known as the rate of per kilowatt of maximum demand. X is considered as known as the maximum demand. Okay, when the maximum demand is 1 kilowatt, the rate total amount will be less. If maximum demand increases, this first term will increases, and as this term increases, the amount of electricity or total billing amount will be going to be increases. Okay, that is the first one. Second one is, as we already know, similar to the straight line or the block meter type of method, where energy will be generated or the billing cost of the energy will be increases or the total amount of will be based upon total amount of energy consumed by the customer. Okay, so in Hopkinson demand rate or the two-part tariff method, we have to consider the two part maximum demand also and the energy consumed by that particular customer. Now, the last method, that is the Doherty rate or three-part tariff. Now, whatever the residential electricity bills you received, it is based upon this tariff method. Okay, in India, we are using this tariff method, that is Doherty rate or three-part tariff. Okay, so in this case, whenever we compare it to the previous one, we have to just added some fixed amount in that particular or some fixed amount or the charges which has been added in this particular system. Okay, so it is the modified by this particular rate method is it modified by specifying the minimum demand. Okay, so we have to consider the maximum demand, we have to consider the total amount of energy consumed by the customer, and we have to also consider some fixed amount in addition. Okay, so it is very similar to that basic equation that we saw in the introduction part. So the Z is equal to AX plus BY plus C, where A is known as the rate per kilowatt of maximum demand, B is known as the energy rate per kilowatt hour, and C is known as the constant amount charged to the customer during each billing period. Okay, so this particular duality rate is sometimes modified by specifying the minimum demand and the minimum energy consumption that must be the paid for. Also, they are less than the minimum value which are the specified when the generating capacity is less and the demand is high. Okay, generally in India, what will happen? The electricity generated is less than the requirement or the demand in the demand or the requirement of the customer. So in that case, we are using this particular method. Okay, so in this, what will happen up to the certain power consumption, the charging rate is less. We can say it is the rupees 1.5 per unit up to the 50 kilowatt hour. When it exceeded the limits, its charging rate will be increases, rapidly increases. Okay, even if in your residential cases, if you saw up to the 100 units, charging rate is nearly 3 to 4 rupees per unit. When it crosses the 100 units, the charging rate will just double. It will be near to 6 to 7 rupees per unit. So similarly, where the actual demand is very high, but the generating capacity is less, in that case we are using this type of tariff method. And always in most of the in development nations, developing countries, in India, China, like here the demand for the electricity is very high, but the generation capacity is less. Okay, whatever the electricity generated is less. So to reduce the demand, we are generally use this type of tariff method. Okay, so that is the last type of tariff method. So this is the end of our chapter number 2, that is economic analysis of the power plant. Okay, so the numericals will be based upon tariff methods. I will share one different videos which will include it, which will consist the detailed solution of the numericals based upon tariff method. Also, one video based upon the load duration curve and load curve. Okay, I will share it. I will share it later on, which will based upon the numericals of tariff method and also the numericals of the load curve. For your MSc, there will be only numericals will be based upon only 2 points. One, that is the load curve and load duration curve, and second will be on tariff method. Okay, there will be no any numericals on economic division or any operational and performance characteristics. Okay, so if anybody have any doubt, you can ask now. This is the end of our chapter number 2. The whatever the point which we covered in our PPT, only prepare those points, and there will be a numericals based upon only 2 points. First, that is the load curve and load duration curve, and second point is the tariff method. The numericals, the videos which is solving those numericals or the videos related to that numericals, I will share it later on. Okay, just see those see those videos. You will understand how to solve these. Those numericals are very easy. Okay, we already discussed the numerical which is based upon the load curve and load duration curve. Okay, similarly there are some numericals based upon the tariff method. Those equations which we discussed here, the same equations has been used to solve those numericals. Okay, you have to just calculate the total electricity bill or any other variable. Okay, so if anybody have any doubt regarding the second chapter, you can ask now. I already shared the recorded sessions, so you can watch those sessions